So thanks. I love for the invitation. I'm going to talk about something, that is quite novel because there's not many applications like that. And and I also I'm planning to do a lab demo, which is always a bad idea because it always fails, but we'll see. So I don't expect anybody to know me, so I'm just going to do a quick introduction. And since I'm the only speaker, there's nobody can do the introduction for me. I can do for the other person. So I'm from Switzerland, but not everybody's from Switzerland here. So I'm not from the bad part of Switzerland, which is French speaking, right? And on top of that, my parents from the Italian part of Switzerland, which is even worse. So no, I'm sorry, guys. Just kidding. Actually, I love it. So I studied here, but I leave most of my professional life outside Switzerland, actually. So I worked for IBM. I worked in the research division in New York and Tokyo. That was when I finished my PhD in Switzerland, EPFL. I work in the research division, and I think it's a good thing because it makes you think a bit like everything is some kind of problem to solve, and you have always to put your personal touch. So I think research is a good thing, but it gets old. So eventually I moved out, and I created my first startup called Strong Codes in 2013. And that was, I'm a background in cybersecurity, so I do love cybersecurity. That's what interests me. I don't know, I expect anybody to know what code obfuscation is, but this is what we did with Strong Code. And eventually we got acquired by Snapchat. Perhaps you know Snapchat. I have 2 kids, so I know Snapchat. And eventually I left Snapchat because what I like is to do products, and I created a store network. So the company, I'm part of it now. And this is, part. So we have a platform. I'll show you a bit this part of the demo, but I'll tell you exactly what it is. So what I really like also is to write. This is what I like to read, but also to write. I think it helps me also to make more concrete ideas. But I write a bunch of stuff. You can be obviously on a website. A lot of things we do because it's about part leadership. I want to make sure that people understand what we do. But I had somebody told me yesterday, but you don't say everything in the article. I say yes, because if you say everything, everybody's going to copy. So it's always a game of how much you say, what you write. So if you think this, there's something missing, it's on purpose usually. So that's one of the things. Is that's why you do a startup, right? Everything is going very quickly. By the way, I like to write about, for instance, that kind of topics, information security, in the age of acceleration. This is from the book of Thomas Friedman on Thank You for Being Late. Also about open innovation and design thinking, something I'm really interested in. So I was mentioning a few things, and also job theory for the late Christensen. Actually, the guys from Lufthansa yesterday, they mentioned Christensen. So I was like, oh, we're not completely outside the topic. So it's different thing, but it applies to many things. So I segmented this talk in episodes because that's what they do on Netflix, right? Every time I want to watch a movie, I see that's a cool title. I said, oh, it's going to be 8 episodes. So I'm going to spend 5 hours watching this thing. So I'm thinking that, everybody's doing episodes today, but I'm going to stick to the time. So why I do this is because actually applying platform engineering to the coding stage is something that is really done a little bit. So you can see in the background, actually there's it's done with containers. Yeah, we can actually have a container registry, and you can prepare a lot of the environments that developers will use on their daily basis, and they can download the container, they can work locally and all those things. But that's not what the coding stage is. There's many other things that I'm a developer myself, so many things that we do with our laptops, right? So what we do, we have M files, we have keys, we have, we integrate this with the DevOps tools, the DevSecOps tools. We need to choose the IDE, you need to put the plugins and all things. So there's many things actually that are not addressed, and providing a container for development is not just a small part of the thing. So what I was thinking is that why don't we try to apply platform engineering to actually create an entire onboarding for a full onboarding for a developer. And why is this important? Because actually in many industries, onboarding a developer is something that is very long. When I was working at Snapchat, it took us about 2 to 3 weeks to onboard a developer, and it's not only technical things, but they're technical things. And I remember you get your laptop, and then you have to install a bunch of things, you have to download things, you have to connect to repos, you have to clone the project, and the Snap app was I don't know, many gigabytes, so it takes forever because we have a VPN and all things. So it's really was really painful. So think of if you do this with a team. So my goal here is basically, why don't we try to use platform engineering to accelerate the onboarding of an entire team? And when I'm in a team, it has to be an onboarding that that is compliant with the organization policies. So there will be risk controls, there will be security, there will be laptop configuration, there will be access control to repositories, to data sources. It could be anything that you require. Everything you require is so that when you get access to your machine, you don't need to do anything. You don't even need, well, you need to authenticate to one thing, but only one thing, but you don't need to authenticate to a million, tools and all those things. So this is what I was thinking we could do. So this is like, I depicted this way. So that's the platform engineer. So it's going to actually create a project, and we're going to, be part of the project. All the users can be part of the project, and they have got a specific role for this project. Could be developer, could be lead, and so on. Also, we want to have some statistics before we do. So some predictive analytics. What's going to cost us, for instance, to run this project, like for 6 months, how much it's going to cost us in terms of cloud resources. The second thing is that we can do prescriptive analytics. What kind of machines do I need because I have a certain workload to work on? So what kind of machine do I need? Like 8 CPU, 100 CPU, 120 CPUs, and so on, and so on. And then I want every single machine, laptops of the developers to be fully installed, fully secured, with all the access to the resources. The resource can be very, diverse. Like you can have Git repos, secret management tools, SSH machines, containers, and so on. So that's what I'm trying to do. And by the way, I'm trying to be very short in this presentation because there's no time to go over all the things. So I wrote an entire article that I will publish, but I've already sent it to a few people. So some people who could not attend today, I should send it to them. So I have it's about 10, 12 pages. I wrote a complete article of what I'm explaining today, and feel free to ask me for preprints, and this will be available. So episode 1, the online app. So first of all, if you want to achieve that kind of feat, creating this entire team, we actually first need to think that development environment can happen in the cloud. And I think this is one of the things that the trend that is very interesting recently is that a lot of development is moving directly on the cloud. I'm not talking about Git repos and all things that's being on the cloud for a while. I'm really talking the coding environment, like your Linux machine, sometimes a Windows machine, but your Linux machine mostly could be online, and you connect to it, and you can code directly on it, right? So you use the computational power of the machine and stuff. And when I heard that first, like, yeah, sure, I was doing this when I was at PFL. We're SSHing to a machine and we were working on it, and that's it. Well, actually, we want to do this, yes, exactly the same thing, but in a much more friendly way, and it's going to be totally transparent to you. You don't even know that your environment is not on your computer. So this is it. So we have software container, and we can actually use Docker locally. Everybody does that, provides the isolation of dependencies, so it's a good thing and stuff. But actually now a lot of companies are putting a container online, and there are many solutions for that, right? There's the big clouds, they have like Azure have code spaces, they also DevOps, Google have a workstation, there are a bunch of startup like can have also like open source project and all things. This is called actually a CDE, that stands for a Cloud Development Environment. This is something that became a Gartner category last year. And so there's the Agile and DevOps report. They talk about that thing. And this is where the industry is moving. And actually, I wrote extensively about this in my articles. I actually looked at the whole history of moving data from a local machine to the cloud. And this happened to CRM data before. It happened to a bunch of other type of data. And last but not least, it happens to development data. And one of the things is that it's not that we only store this online. We also provide compute for this. So basically, when you compile with this, actually don't use your machine, you actually use the computation power of the cloud. So if you've never seen that before, and it's actually emerging technology, I can quickly show you what it looks like. So this is a platform that we use ourselves. So this is the platform, and I'm connecting to this platform, and this is those are machines. There's actually an avatar for small Linux machines. It's like the whole team is working here. You can see what's running machines and so on. This one needs to be updated. And like, if I want to start working, I can work with VS Code, and that's it. And I'm starting to work. And this is my machine, and this is a Linux machine. So that, The latest machine, this is like normal Linux that you have, and sudo on this machine, so I can do, apt update and all those things, upgrade and stuff. That's it. This is like my machine, right? And this is a Chromebook, so I didn't install anything, right? So I like Chromebooks. I don't want to move to anything else, but I need to code, so that's what it is. So for convenience, it's really cool. And with this platform, if you have used CodeSpace before, yes, you have the same kind of IDE. Actually, it's the same IDE as VS Code. But here, this platform, we also have access to the GitHub repository, and we access this here through a secure browser. So if you know what an enterprise browser is, like Island, Talon, and Citrix, they have one as well. This app platform combines both. And I'm going to tell you why it's important, because this is actually the only way to provide some types of security. And this is why this is working like this. So this is a machine. You can actually create any machine. And if you haven't seen that before, that's it. You can connect with the VS Code in the browser, but also with the local VS Code, with SH Remote Dev, and so on, or even like a terminal. So if you haven't seen that thing, this is what it looks like. And it's not only platform, obviously. There's many platforms, but at first sight, they look the same. So let's see what we can do more. So that's episode 2, the security. So actually, what I said, the problem I'm trying to solve is that I'm not only trying to create environments on the cloud, I'm also trying to secure everything, because actually organizations, they have security policies. They can't, let their assets just, get already. So they need basically to have some control on it, right? So what's happening is that here I also need to figure out how can I secure these laptops, and security policies can be over the infrastructure, over the code. So you can say, well, I don't want actually to have any type of extraction possible, like source code should be protected, credentials should be protected, but also the code also should be free of vulnerabilities and so on. There's actually many types of security, but we're going to see how these things can, at least they will colleagues, which is one interesting thing. So how do we secure the cloud development environment, the CDE? So how do we secure it? So that's one of the other things. So this is exactly what I explained just before in the demo, is that this will be a normal cloud environment development, like if you think of CodeSpaces again here, when you have like your container online, you connect and you get your IDE and stuff, and that will be a secure cloud development. That's what I just demoed before. And in order to provide security, well, you can't just have an IDE on demand. You actually have an IDE and a secure browser. So it's a lot of work, because you need basically to implement both. And the IDE will provide access to the container, and the secure browser provide you to application, all the application you use for your work, like GitHub, Geo, anything that could actually be authenticated via SAML or OAuth. And every access is via proxy, because that's one of the key things. Why do we need a proxy? Because you don't want any credentials on the developer's environment. Because why? Because they're sensitive to phishing or malware, this type of thing. So credential theft, you can see in the news, actually Slack, Circle CI, Okta, of all people, they got hacked with credential theft. So and Mercedes a few weeks ago. And why? Because they credential on the environments, credential on the repos and stuff. So that's something that is really, so credential sprawling is something that obviously we're all aware of. So this is the goal here, having everything go to a proxy, is that you don't have that problem and you're solving that problem. So that's the third step. We need to secure the cloud. So once I have the security in place, I'll be able basically to, this is the next step to get to my TMS code. And what we do now, actually, because we have this protection here, we actually control the infrastructure. So when I'm talking about infrastructure, don't get me wrong, we control what's really all the interaction between the information that gets in the system and out of the system, right? So this is basically like I have control on what's people doing here. I control the clipboard, I control the network, I control everything that's happening here. So this is every way the information will flow in and out of the thing. So if that reminds me something here, this is basically what Citrix would do, right? They would actually provide a VDI with in order to prevent exfiltration of data, right? But it's not a VDI at all. This is like very far from it actually, because this is purely local code, and it will execute in a web browser, so there's no issue with latency and all things. So that's basically it. And actually, the idea initially when we started working on this, that we're going to do a VDI killer, Citrix VDI killer. But the irony is that today, actually, Citrix is the biggest client, so it just became the biggest client. So at the end of the day, so the surprise. Why did I tell you that? But because the surprise. So what happened? And so what we realized, it perhaps this coolest insight when you work on things like that is that we're always thinking that, this infrastructure security, the way we're trying to prevent things in and out, and we need to put this to be compliant with the organization policies, so this TMAS code. And but also this code security. And those are different things, right? Code security, you scan your code, you make sure there's no credential in your code, nobody copies this thing like this. But what happened is that when I'm working here on my project, this is an avatar against the Linux machine that is running, that can access with the VS Code, SSH, and all things. So initially, we prevent data loss prevention. We don't want credentials, we don't want code, we don't want data to go out. But what we realize is that once you control the infrastructure, why don't you look at what's coming in? That I named this data intrusion detection. Okay, so don't Google this because you won't find anything. This just came out with that name, right? And an article. Why? Because we patented the whole thing. That's why I wanted to make sure that everything is patented before. But what's the goal here? Because you have control of infrastructure. You know the business process. You know what people do, what they do. They do code, right? So when I see a credential in my clipboard, what do? I say, hey, good job. No, it's not a good idea to put a credential in the clipboard. So I say, stop. No credential in the clipboard. Why? You're going to copy this in the code? Nah, it's not a good idea. Right? Or if my guy go to Stack Overflow, I copy some code, I paste the code and say, why there's an open source license Apache attached to it? What are you going to do? You can't actually release the code, right? So there's all these things that when you control the infrastructure, actually infrastructure security becomes code security, which is a really cool insight, right? Just realize that stuff. So and obviously there's malware, certificates, and all the credentials and all things, right? Personal data and all things that we can see, all things. So this is, once you know this thing, then you can. So I was thinking, once now there's a pattern, I could write that into this is even a thing for code development, because you have to explain basically why this is a cool thing. So, and just to show you that this is possible. So let's say if I just go there and I restart my machine, and what I'm going to do some very bad stuff. I'm going to cat my key. Why would I do that? And I'm going to copy my key here in the clipboard. And then I'm going to go, I'm security officer on the platform, so I can see everything. Oops. There you go. Get detected. So now I can apply policy. Do not copy this. Do not do that. Right? So this is an example, an insight that when you control the infrastructure and you know the business process underlying this infrastructure, then you can do things that you could never do before. That's why people like Citrix, Citrix is general stuff. It's not made for development. They can access Excel. So whatever goes in the clipboard, you cannot really any kind of semantic analysis of this thing. So it enables basically semantic analysis of this thing. So we're almost there. So, by the way, with secure CDEs, there's a lot of new things that you can do. And what I think I did, I wanted to rethink of DevOps, because obviously, like everybody, I'm a big fan of, especially the DevOps handbook. So, I was rethinking what happens to the principle of flow, the principle of feedback, and the principle of continuous learning once you have code online with security. Because you can think about a bunch of new things, right? So that was published a few weeks ago in the new stack. So now I can start putting it somewhere else, because I have exclusivity with them for a few weeks. I think they asked for 2 or 3 weeks. And you can see, and if you're interested, I'll be in Bern, actually Nadine, who's hosting the DevOps meetup. Bern, I'll be talking about that topic. So I'll be focusing on only the novelty that can happen with DevOps if you actually use this kind of technology. I think there's a lot of new cool things you can do. So the abstraction. So we're almost there. So now that we have you have coding on the cloud, we have security on the cloud against data exfiltration and infiltration. Now we can say, let's actually create an abstraction of this machine, not only the container, but the entire machine. That's I call this a virtual secure laptop, because this is what we need for the deployment. We need actually virtual secure laptops, because, we're not going to give real machines. Why we don't do this? Because you can actually use BYOD. People in security say, yes, you need client attestation. I say, yes, we need client attestation, but I'll speak about this another day. But if you have a good security model like the Chromebook, or I said the Chromebook because I don't see anything else. then basically you can go away with the BYOD, and you can actually distribute secure laptops, reasonably secure laptop in BYOD. That's one of the things. So we need to create an abstraction of that. So one of the things is that the simplest abstraction you can say is that this is my secure laptop with a lot of stakeholders. First, I want to have developer experience, because that's the most important thing. Again, if developers, they're not happy with the machine, that's not going to work. So you have to foster and make sure developers' experience is taken care of. Then you have DevOps productivity, you use dev containers, dev files, and all things. And then also you need to have a virtual machine, right? So actually virtual container, virtual workspace. So you need also to control the asset utilization, how much CPUs you consume, the region where you deploy it, if you want to have a special region, the schedule. You can have special schedule how you run the machine, because you want to obviously minimize your cost. And this is one of the good things about this. You can really pay on demand, because actually when the machine is down, actually your resources are free, then you don't pay for it. And you also, this is very important, you want to say what access is granted to this machine in advance, and you want what policies are applied to this machine. Why? Because the advantage of having this secure cloud development environment is that we can show we have a proxy, we control authentication. So actually imagine this, you can work on your machine and you have access to all resources, you never need to authenticate again. That's really cool. I mean, a developer, I really SSH keygen, and I then have private keys over my thing, I don't do that, right? So you want to basically completely remove the need for keys, completely remove the session tokens that you get from authentication that will be on your machine. You will completely remove that kind of thing. So that you want to have a machine that not only have all the developer personal preferences, but also that makes their life easier. We call this actually productive security, and you actually don't want to be like everything you're going to use is like you were unauthenticated, but actually strongly authenticated by the proxy. So we're going to destroy this monolith, and this is how it looks like. So not all the parameters are there, but this is typically the parameters of the template that we need to do the TMS code. So every machine going to have a lot of parameters like this, and they're going to be defined in YAML for the details. And we're going to create this with the API of the platform, and so this is for the developer, your M file, DevOps to connection, personal secrets, and if you obviously everybody knows about what's personal secret. But when I showed this to my mom, she was there. What do you mean, personal secrets? So, GPG keys, schedule, startup script, ID customization, identity, your own personal SSH identities that will manage through the proxy. DevOps productivity, container terminal, web ID, local ID, all these things, and all the data access control to Git repo. You also want to give access control to HTTP services, SSH services, TCP services, so you don't have to authenticate to a database. It could be anything like IBM cakes and all things like for the old people. So, and then development secrets and default apps and desktop and all things. Data security policies, network traffic and all things, keyboard content. So you can see, you can really parameterize a lot this thing, and that lets you do the TAC, the TMS code. So this is how it works. So to create this TMS code, we're gonna, this is where it failed because the demo, so we'll see if it works. So what we do, so we actually create a Jira task, and it's a Jira task, and we say, oh, I want to have this guy under, with this template for the machine, with this security policy and so on. And what I want to have is basically all this created there, the API, and the project is created, and everybody can be on board on the platform. So this is where I start Jira, and this works, but let's see. So let's put the DevOps days Zurich. There you go. And then here, I'm going to put the same thing from a project name. And then I'm going to say, oh, let me take the DevOps template, and they take the intro policy, and let me invite Oz. Oz is my partner, so I'm going to put it here. There you go. I'm going to invite Bastien. So I'm just, the issue that my eye is not good, so there you go. And invite Bjorn as well. There you go. So is that correct? Bastien thing. I'm going to create this thing here. The task is here. I'm going to put it in execution and stuff. And then let's see what's happening. And we created the new project here. So we created the project, and there you go. Oh, was this created here? Let's go to the demo cluster, which is a little different. And there you go. The machines are coming up. So I created 2 machines, and now actually these guys, they just log into the thing and they can start working, and everything is configured. Their personal environment files, their ID, their plugins for the ID, obviously the container, the connection, they authenticate it to all the resources they need to do, the DevSecOps, DevOps tool, Artifactory, and all those things. We have a native integration with Artifactory, the CLI is it OBS, CLI is GCP, depends where you are. And and that's is deploying the machine, and like few seconds, I think this should be good. So yeah, so that's TMS code. So I know it's not very super impressive when you do this with thing, but there's a lot of things that happen in the background. So just wait, and so let me just conclude. There you go. And what can we do? The cool thing we do is like with the API we get access to all these metrics. So we can do some prediction. We can say how long it's going to cost us all to have this cloud to run this team like for 6 months with the machine, or prescriptive, as I said, like what kind of machine do we need, and so on. The conclusion. So if you want to have a thorough conclusion, read the article. I actually approach benefit of predictive analytics. I explain how you can mitigate tool sprawl, productivity, policy compliance with all those things. So this is, I think, if you're interested, I can send you the article. This is what I'm working on now. So if you're interested, this is also things that we're looking at: cloud native application protection strategy using this type of infrastructure, which I think is good for in many enterprises. If you like t-shirts, I like skulls, so I have this kind of shirt, but you can have also this one. I took a bunch with me, so you feel free to come and then want that. Yeah, if you want to connect me, then that's it. So yeah, and a few minutes for questions.
Perfect. Thank you so much.